got Jed, Brad, John Matt. Okay, we're doing great. Okay, so a quick introduction. So this of Macnica Americas, we have John Mayotte, who is system architect for IP convergence at Imagine Communications. And we have Richard Hasty, senior sales director, Mellanox business development at NVIDIA. I think our titles were like a pyramid. They kept getting longer as we went down the list. So anyhow, I'm going to turn it over to you, Brad, and looking forward to a very engaging discussion. Thanks.
All right. Well, thank you, Wes. Appreciate the introduction. And hey, guys, very good to see you. Definitely looking forward to the time when we will be able to see everybody face to face. But in the meantime, this is a great way to get together and have a discussion. So I think in the earlier presentations, people talked quite a bit about Nmos. I think I really appreciate the presentations by BBC about their implementation with their project, and I know there have been a number of other companies that have worked on implementing Nmos, and so this is a frank discussion about Nmos. I noticed in the BBC presentation that it said Nmos should do orchestration, which I thought was a good comment and good input. And by the way, myself, John, and Jeremy are on the AMWA board. So guys, that message went straight to the board. We appreciate that. But I think before we can have a frank discussion about Nmos, we probably need to talk about what it is, because it's not 100% clear to me whether in BBC's slide where they had that point, it was like Nmos should do orchestration, that's a suggestion, or Nmos should do orchestration, but it didn't, it failed because it didn't do that. So I think there's describing what Nmos is and what it isn't is probably worthy of a few minutes of our time. So is there anybody that would like to take a crack at talking about what it is to start with? Oh, Rich, you're muted, I think.
I was going to say, go on, John. I've seen your excellent videos on what Nmos is and isn't.
Well, there's two. We use the word Nmos colloquially to mean two different things. So there's a large-scale project of the AMWA called the Network Media Open Systems or Solutions or something like that.
Another specifications, but that's okay.
Specifications. And it's a large-scale project that's gone on and has a past and a future and a roadmap and is a kind of collection of standards and specifications and documents to try and move the whole industry forward on a lot of fronts around these networked media solutions. And then we also use the term Nmos to mean kind of specifically this sort of connection management ISO 5 and discovery ISO 4 part. And this has caused some confusion because on the one hand, the big project, the Nmos, collection of people and processes and things is, has many goals and is moving forward on a lot of fronts. But the specific, connection management stuff is actually finished work and has been for some time. And as the BBC Wales guys pointed out, it was early days of connection management when they did their project, so it wasn't quite there for them at that moment, but it is being deployed pretty successfully, the connection management part of Nmos on projects today.
So that's an important thing to note. What about security and is Nmos security for IP installations?
So as we, go ahead, Jed.
Go ahead,
Yeah,
Jed.
yeah, I can jump in on that one. Yeah. Well, security is certainly a layer that we need to consider, and that's something that's really been sorely missing in the past. We didn't really have a standardized way to do that in SDI. But because Nmos is an IP communication mechanism, we can add security layers that have been proven in the IP space, TLS 1.3, for instance. So if you think of Nmos from an implementation standpoint, we're really just sending these very simple HTTP puts and gets across the network saying, give me your status or let me change your status. So there's nothing preventing us from wrapping this layer on top of it called HTTPS, the secure version of that allows us to now secure these communications. And Nmos has done a great job of specifying exactly how to do that.
Correct. Yeah, and thank you for that. That's a great clarifier. I think that it's important as we define this, as the starting point of our discussion, that doesn't mean that Nmos specifies security around PTP. Does it, Rich? Or around 2110 streams or access to a 2110 client, does it? Can you talk about that a little bit, kind of the limit of the scope of that within Nmos?
So if you look at Nmos, there's actually a lot of detailed specifications, and there's been a lot of time invested in security. Now, security is a bit of a general term, okay, and covers many sins. But in reality, what has really been focused in Nmos, because Nmos is the control layer, okay, so let me be specific on that point, is the encryption of the control layer. So how do I make sure that someone sat in the middle of the network doesn't listen to what I'm doing? So encryption and the protection of the information. And the second thing that has been done very extensively is the authorization, because obviously you need to make sure that if you have a controller, that controller is authorized to do certain things to certain devices within the network. Now, because Nmos is the control layer, it's not the transport. It's not moving bits or the video from point A to point B. This is the control plane. Likewise, it's not doing the timing. So, PTP is, for all essential purposes, out of scope as far as Nmos is concerned. But Nmos itself has a very mature set of specifications that covers everything that's necessary to do security, encryption, authorization, etc.
Great. That was a very clear answer. I appreciate that. As we're, again, just kind of defining what Nmos is Nmos a product?
Well, I can speak to that one as well. It's a specification, of course, but it is available as a product, and that's something we.
What do you mean by that, Ted?
Yeah. So we at NextEra provide Nmos cores to broadcast manufacturers that would like to adopt Nmos, which we hope is everyone, to really accelerate that process. So it runs on any FPGA core, any 2110 implementation, any OS, any platform. So that's something that can be purchased and it's supported directly through us. But
so in your case, you make a specific product, but then of course from the AMWA perspective, Nmos is a set of API specifications and specifications and best practices about how to use security properly, for example. So it kind of depends on how you look at it, right? So in one case, yes, absolutely, it is a product. In another case, it's something that, Imagine or others might deploy in their products. So kind of it depends on which part of the elephant you're looking at here. Jed, it looks like you had something else to add there. Go ahead.
No, just echoing what you said. It's a specification that can be implemented by anyone directly by themselves, or it can be purchased. So it's up to the equipment vendor.
So
Okay, great.
Right.
it
In
might
fact,
just be
it's kind of
worthwhile.
it's kind of the opposite of a product. It's free in a sense that the specs are available online. There's open source implementations available online for, nodes and controllers. They're obviously sort of examples and a little bit limited, but they are, they exist, and many subsystem vendors like Nextera or some others actually supply Nmos code along with their 2110 implementation, bundled or separately. It's pretty widely available to equipment makers.
Rich, did you have something to add there?
Yeah, I was just going to jump in and say, just to add to John's point, the actual specifications are free, but it's important to understand the state of those working groups and the specifications, because that's really where it hits the group. So just for people's clarity and understanding, the AMWA board elevates the work as a specification, and it doesn't do that until it's gone through a proven interoperability with multiple vendors being able to adhere to that specification. So that gives the industry the warmth of the fact that multiple people can do this. And then the board actually elevates it again into what they describe as a stable specification. And actually that's a step above, because that's really where that specification has a proven track record of implementation and actually actively being shipped into end users and being consumed. So actually any organization, whether it's a vendor or an integrator or even a customer, can go and look at these specifications. They can see exactly where they are, and they have the warmth and the comfort of the fact that if it says stable specification, it's in the marketplace actively being used and run.
Yeah, and just so to draw attention to that, what John said was ISO 4 and ISO 5 are done and dusted and have been for a while. And those do have that stable tag on them, and didn't at the time that the BBC Wales project was going on. But then there are many other projects in flight within the AMWA that are going to result in either specifications or best current practices. And some of those are going to add functionality. In fact, many of those are adding functionality beyond just registration and connection. And so it's really an iterative way of working rather than producing one massive kind of control plane specification that's 500 pages long. Jeremy, I wanted to come to you for a moment. People may or may not know that Magnica is involved in the IP or the AV over IP space. So you might just say a word or two about that, and I'll come to you later to talk about Nmos and IPMX work. But I just wondered, doing what you do, which you might briefly explain to folks, how do you view Nmos? Is it a product? What is it, kind of from your perspective?
Sure. So we come from a similar place that Nextera does historically, where we developed some D2110 IP and absolutely integrated Nmos into that. But we've also expanded our offerings into what I call the Pro AV market. And that's, we see that as critical. To give a bit of definition around that, that would be everything from live production at the high end all the way down to enterprise markets and office buildings, things like that. So the critical thing for us with Nmos was interoperability, because the Pro AV market is even more fragmented than broadcast and a lot of live production. So having a clearly interoperable spec was important. And you mentioned IPMX, and I think we'll come back to that. But that was kind of the goal around that. And you really can't have true easy to use interoperability without a good control plane. So from my perspective, Nmos was a very simple, obvious choice for that. And we view it as an open API. We leverage a lot of open source. We also created our own implementations earlier on. So it's very available, it's very open. And as you mentioned, it's stable, but at the same time, it's flexible enough that it can be added to. And as long as there's backward compatibility, we see that as being a good thing, because these are fast moving markets that are software implementations. So all of those things we really need, needed as we moved into the Pro AV space.
Yeah, so we'll talk about that potential connection later. But you mentioned control plane. I think Jed did. It's come up several times. Rich talked about that. My background is a number of years at Turner and working in the Cartoon Network, TNT, TBS, working for Turner Sports and Olympics and NFL, NBA, all of those things. And when you talk to me as an end user about the control plane, that's a huge area. That's a huge swath of land. And so when we talk about Nmos operating in the control plane, or Nmos is the control plane or whatever, honestly, I get a little bit nervous, because that encompasses huge amounts of functionality, and Nmos addresses some part of that. And I think potentially working together with the SMPTE and the VSF on some of the 2110 over WAN and GCCG, ground to cloud, cloud groundwork, and in IPMX, I think that we can all work together to address issues in the control plane. But the control plane has many different layers in it. From my perspective as a user, or the business systems that start talking about program planning, and we've got an NBA game, and then after that we're going to go into movies, and then so on. Is that in the control plane? I don't know. If you're talking about systems where in the past maybe we had a studio that we had technicians go in and build, they put connectors on the ends of cables and set monitors where the producers and the technical directors wanted them in order to do a James Barkley on the NBA halftime show or whatever. That world is very quickly changing, and those facilities cost a lot of money. We used to down a facility for maybe a month to rebuild it for a new sport. And there's a lot of money to be made in that. And now the promise of IP is that with the push of a button, you can reconfigure that room, and it was doing NFL in the morning, and it's NFL Monday evening, and Tuesday it's covering, I don't know, the start of the hockey season or something. And if you haven't lived in this world, you may not know, but we used to spend a month reconfiguring the facility because the user requirements in those rooms to do those different sports was vastly different. And now, John, I know you've been talking to some sports franchises about this. Maybe you can talk for a few moments about that, what users are looking for now, and maybe talk in relation to Nmos. And does Nmos provide the control layer to do that? Where are we with that?
Oh, sure. I mean, this problem is not new for IP, right? This is a problem the industry's always had. But when we move to IP, there's this idea that, well, I can now build a big enough underlying infrastructure that all the cameras, all the switchers, all the replay machines, everything can be on this shared infrastructure. And so there's a cost savings idea that comes up that says, oh, that means I can take a studio and repurpose it to this show, that show, so forth. And that's a great idea and it's a great notion. But what happened historically was that each studio, as you say, would have a month of changeover where everything would be reorganized for the next show it was going to do or the next purpose it was going to serve. And now there's a desire in the industry to have a more automated process to do that, perhaps in a morning instead of a month. Well, that's all possible, but it's difficult because a lot of what those people were doing during that month of changeover wasn't so much moving cables or rewiring as it was reprogramming tally systems and names and associations between channels on switchers and things in the world and all the kind of production specific associations and production specific definitions. So now there's a lot of interest in the world in how do we mechanize that? How do we mechanize that production definition? Now, somebody, Pete, as we talked about right at the outset of this discussion, there's the big Nmos, meaning the project that has many phases and parts and things we're working on. And then there's the specific, like connection management. So connection management, it's done, it's dusted. Yes, it's being extended to some new things, but everybody in the room is super critical about backward compatibility because there's so much running system in the field. Now, Nmos and its, subsequent, phases working on how do we define the production layer? How do we define the control layers across a more broader spectrum of functions? Okay, that's new work, and that's work that is starting and is ongoing, and that's the work we're starting to really focus on as the next things inside organizations like the AMWA. So
well, we've got the
watch
modeling
this space
and
and participate.
Some people might have heard about the modeling work, but that's not what we're talking about here, right? And
right, the modeling,
it might be helpful if the industry, because there are entities, and I'm sure some of them are attending this. That's what they do, or they do parts of this. But tackling this problem in an interoperable way, I think one of the powers, the values of doing some modeling work ahead of time is that people have kind of they know what to expect if they're going to try to interoperate, right? So we have a modeling piece of work underway, maybe just briefly, because we've got some other things that we want to go through. But can you explain why the current modeling work isn't going to deliver this? Because this is a frank discussion about Nmos. That's the title of the panel.
Right. Well, I mean, there's 1,000 problems in the world, and we have to tackle them in some order. So the current modeling work in Nmos really started on the notion of, for inside a device, a video processor, an audio processor, a mixer, some device that does a thing. Currently, Nmos defines connection management. How do we get signals into it and out of it? But it doesn't cover anything in between. How do we expose controls in a common way? If I have a color processor and it's got an RGB gain control, and say Grass Valley has a color processor, it's got an RGB gain control in the middle. It'd be nice if there was some common exposure such that a controller could look at a device and say, hey, look, it has an RGB gain control. I know what to do with that. But currently the world doesn't work that way, but it could. And so there is enough interest across vendors now to move forward on this topic. So that's what the Nmos modeling project has been focused on for the last couple months, is getting to where there's a common control architecture that at the device level for exposing parametric controls, statuses, so that they can tie into monitoring systems in a more organized way. Because if you look at where the cost goes in building a large project, a lot of it is in the customization that every device has a different API. So that's all good, necessary stuff that has support, cross-industry support and people working on it. But that still doesn't tell you, why is this signal in this device? Why is that camera needed? Who's the director today? All the production information that goes with standing up a specific production. Not to say that it can't be extended, it can't have, some tentacles up into that, but that definition of the data structures of a production is a new piece of work. And high time to get started on it probably as an industry. And there's some work going on that in SMPTE. There's some work starting on it in, in AMWA and other organizations, but that's the new big project, I think, for the industry, is to get focused around that.
Yeah, I think so. So the modeling of devices is a piece of work. And I think you and the group is just following good engineering practice in the separation of concerns and control of scope. We start with the devices, but that work is not yet focused on systems or gigs, and how you would model that. And, ultimately what people like me that are in the user community are really wanting to know about is, what's the relationship between the content and the streams that it's on. And at the end of the day, it's about the wallet, and that connection is not delivered by Nmos or JTNM's reference architecture or anything else yet, and that's another piece to be done. So I think part of the point here is a frank discussion about Nmos, and that leads to the question: when will Nmos be done? And I'll just respond as the executive director of the AMWA. I'll take that one and say Nmos will, I don't know if it'll ever be done. And I think that really causes problems, frankly, because I think traditionally we have, when will the MXF specification standards be done? When will the SDI standard be done? When will this be done? The fact is that there's 1 year review of those documents anyway. But I think when you're responding to a software-driven world and you're adding functionality and you're taking an incremental approach to addressing a very large problem, the industry is best served by taking bite-sized pieces and working in an agile way. And what we have tried very hard to do as the board of the AMWA is tag things as AMWA specifications, and then as stable specifications that are, locked down and, done, dusted, that's it. And then we pick off the next piece. So we've talked in terms of what's next about potentially the modeling of systems and gigs. We've talked a little bit about this dynamic configuration, and Nmos doesn't do that right now. Nmos doesn't have some piece that says I can go in and do NFL Monday Night Football, and then Tuesday come in and do dynamic configuration and do hockey. What about the use of Nmos beyond 2110? So a lot of people talk about, and Rich, I see you nodding your head there. A lot of people talk about 2110/Nmos, and of course they're referring to 2110 as basically the essence layer, and Nmos is the control layer. And so these two things are just together. But is there any discussion about use of Nmos in spaces other than the 2110 space? I think you're on mute. Rich, I think you're on mute.
Still muted.
You're
I'm
muted.
sorry, apologies. I muted myself. I can jump in, but I suspect Jeremy might have a point as well. Nmos is a set of specifications that they are equally as applicable to one transport as they are to another transport. from an NVIDIA perspective, my organization, we're looking at the use of NMOS way beyond broadcast. We're looking at it in virtual production. We're looking at it in retail scenarios. We're looking at it in, commercial location-based entertainment, all sorts of different use cases. And the transports in those types of environments are not SMPTE 2110. The specifications themselves, as John alluded to at the beginning, are very stable, but they're also extensible. And I know Jeremy probably has a point on this, because they can be extended for JPEG XS or X264, HEVC, all of the different encoding standards. And because of that, the standard, the specification, doesn't change, but it's a very flexible control layer that actually allows the applicability of NMOS to multiple different use cases. So personally, I dislike the fact that SMPTE 2110 and NMOS seems to be tied together in discussions, because I think that's a mistake of the industry, because actually disaggregating these two actually shows the power of what is actually achievable.
Yeah, thank you for making that point. And I don't know if Mr. Rayner is still in the room or he's off having a cup of tea, but what the 2110 over WAN group has done in incorporating the NMOS registry and done some work on thinking about how they would expose resources that are in one facility to another facility is really, they've worked out how to do sharing of resources between two different facilities. And that's something that as users, we very commonly need to do. And it has nothing to do with 2110, really. It has to do with the security and the kind of administration of, I'm going to share this camera and this, this standards converter or whatever, and with a mobile truck that pulled up outside my facility or whatever. So there's an example. But Jeremy, I know Rich was kind of teeing this up for you, but how about in relation to IPMX and Pro AV?
Sure. And quite honestly, you guys already touched on some of the key points there. This is really, if you look at the Pro AV space and where it's heading and how quickly it's heading there, the ability to orchestrate kind of across, on-premise, off-premise, in the cloud, between microservices in the cloud, all of that, it's all about the control layer there and how you actually make the, move the essence between nodes is, from an NMOS standpoint, really needs to be, essence layer standard agnostic. For us and what we're doing with 2110, the current focus is, for IPMX, the focus is still, to be honest, quite heavily tied to SD2110 or an extension thereof. But the roadmap for that goes, much beyond that. And certainly what we're looking at for is critical. And, as you mentioned, there's the other pieces, there's the security and that sort of thing. When you get into Pro AV spaces, you're very much in an IT world these days. There's a lot of other, standards that are there. HDMI rules right now in Pro AV, and variations of that, but very quickly is moving to an IP base. But you need to be able to kind of encapsulate and incorporate all these other standards as well. So
yeah, and so a couple of points about that. First of all, is that we absolutely rely on the SMPT and others to produce those bedrock specifications that we need. For example, the JPEG XS stuff, I believe, is being looked at for IPMX. So why don't we get into that, the relationship between NMOS and IPMX now? Jeremy, you kind of have teed that up anyway. So I think there's some specific objectives of the IPMX work, and maybe you want to talk about that a little bit.
Sure. So mean, one of the key things for IPMX from the start has been, I'd call it ease of use. And that's critical because you're in a broadcast studio, and some of these you have very, very skilled individuals doing the installations, doing the maintenance, handling all of that. As you get more and more into the Pro AV space, especially as you start to go further from the live production side of things, you need something that's very plug and play. And that's always been a major goal for IPMX. And the work that we're doing in Nmos right now is very much moving us in that direction. They're also having to handle things that with a history of SDI you don't have, such as in the HDMI world, you have the idea of EDID, which is display capabilities, things like that, which much more dynamic environment as well. Suddenly you plug in a different monitor, it can handle different things, and all the equipment needs to know about that. So those are the sort of things that more recently been tackled and that are key for IPMX, because it's all about that ease of use. But at the same time, you have to be in a place where the IT staff in a facility is going to be happy with what you have. So security becomes really critically important for that. And needs to be something that they identify, modern standard, in this case, standard API that they can understand, and they nod their head and go, okay, I understand that. Otherwise, they're not going to want it on their network or anywhere close to their network.
Sure.
And so that's, I don't know if that answers your question, but.
Yeah, it does. And interestingly, I think there's a very good intersection between what you just described and what a lot of people need in the broadcast space in that market. So, a facility like I used to work at, or, any of the large facilities, as you mentioned, you need a $20,000 network switch, no problem. You're actually talking about core quality, carrier switches in these sorts of facilities that are just slinging around huge amounts of data, and the IT network engineering and, specialized video engineers and all of that you would expect in any large enterprise environment. But there are a lot of television stations out there. There are a lot of organizations that are producing college football that aren't actually even broadcasters, and many other uses where that ease of use, maybe some relaxed timing, better interoperability around the control plane, and compressed video, that list of kind of requirements, it hits a lot of the sweet spots that a lot of broadcasters and collegiate environments and whatever need as well. So we'll see what we can do about producing something, and specifically in terms of Nmos, with the capabilities that'll address the issues that you bring to the table. And just orthogonally, I would like to say thank you and Magnika for joining the AMWA board and bringing that set of user requirements directly to us. We really appreciate that.
I appreciate it from the AMWA board as well, because without the API like this, we're not going to be able to make the sort of progress we already have been successful with. And I'll say that Nmos already has a really good base for that connection management, right? That piece is very much there already. It was a great place to start. I think there's been some consternation about how ready Nmos is, and you already brought that up, but the base layer is there, right? So,
well, maybe we should tackle that directly again, and thanks for the great lead-in, Jeremy. How are 2110 Nmos installations going? We heard about the BBC Wales thing, but Jed, why don't we maybe go around the table? John, Rich, maybe you guys have some things to contribute, but let's start with Jed. So how about that? How are these installations going?
Yeah, sure. Yeah, we've got tens of customers out there using our commercial NMOS core on their product, and I'm happy to say we've had nothing but good reports. Fortunately, no frantic phone calls. Oh my gosh, this isn't working. None of that. The issues, as mentioned by the BBC guys, are mostly around PTP or other non-NMOS related things. So the NMOS has been really solid. It's got a lot less moving parts. It was really kind of designed to be as plug and play as possible, and I think we've seen a lot of success. So I think that there was kind of a question in the chat about this as well, like, well, how and when? And when is now. It's out there. It's working, and the vast majority of vendors of 2110 products are providing NMOS along with them.
Yeah, I think almost, every project we do now has devices that we integrate with NMOS. You can't do a project without using NMOS if you don't want to like spend a lot of money developing new drivers for every little widget. So every project we do, there's a handful of core devices that we might have a special driver for because it has some extra feature or because we already had the driver done. But every project we do now, we pick up a couple more NMOS integrations where, sometimes we find a surprise. Maybe somebody didn't read the spec the same way or something, but usually in a quick bit of conversation, it gets sorted out, and it's far more productive for everybody involved. The whole way to think about NMOS, especially ISO 5, is that it's a universal driver for connection management. That's really what ISO 5 is. And we have, integrations worldwide where I don't find out until it's been working for months that, oh yeah, in that project, we integrated with these other things because the field engineers, they try it, it works, and they move on. That's where we needed to be as an industry, and that's where we are. To the original question about, when will NMOS be finished? Did you know that SDI is not finished? I mean, we're what, 30 years in on SDI, and there's still new versions of the SDI specs that come out every once in a while too. So, that's the nature of technology, is that specifications are stable and they're backward compatible, but there's always one more definition of one more bit of it.
So just to add, I'm kind of give a slightly different lens on this because NVIDIA is a GPU and networking company, and we are really interested in NMOS. And we've got organizations a poster organization that actually is using NMOS across 200 plus different locations and tens of thousands of devices, to be honest. And not only is it now, it has a pedigree and a track record of delivery and, more importantly, scalability. If you think of the breadth of how far an IP network reaches, the great work that Andy Rayner's doing, and IPMX, we see this really going a long way, all the way down to the Twitch streamer in his bedroom sending something up to the cloud. They're all going to need this control layer ultimately. And actually, the proof points we already see in the industry, and we can talk to that. It's already executed and it's already there.
Well, we got a very good question in the chat, which goes right to this. How much of these customers are actually using NMOS beyond ISO 4 and ISO 5? And Stefan, that's a great question.
Well, I can say from our customer standpoint, the vast majority have implemented ISO 8 and ISO 9 as well. So
can you maybe disambiguate I think many people may know 04 and 05, but 8 and 9 people, some people may be wondering, okay, great, I need to disambiguate it here.
Sure, yeah. So 4 is the registration discovery, 5 is the connection management. We all know that. 8 is the piece that adds in the audio mapping capability. So you can mix and match audio channels from different streams. And then 9 is the system information. that allows a device to wake up and see where he is, go to a global resource that it can automatically detect and determine, like, what's my PTP domain, what's my announce interval, exactly where am I, so I can, actually wake up and do what I'm supposed to do.
Oh, great. Okay. Anybody else want to take that question from Stefan about beyond 0405?
Basically same answer, that yeah, the 8 is starting to get traction and 9 is available in systems for the most part. Hard to tell how many devices use it yet, but it's certainly easy enough to be there. It's on, it's not complicated to put on controllers, so most of them did straight away. And ISO 8 is starting to turn up on more and more devices every day.
Okay, great. The audio mapping. Rich, did you have something?
Yeah, I was just gonna, if memory serves me correctly, ISO 8 is in the field and it's been a stable specification since July 2020. So it's 6 months in the rear. It's, we've got installations that are actively using it.
Yeah.
Already there.
Yeah. So I think though that, to be frank, if you go back and you look at the slides from the BBC presentation, you're going to see that there are different approaches to doing audio depending on where you come from. And I want to be neutral, non-judgmental about that. I don't have a view one way or the other. What I can tell you is that there are other approaches to making connections, for example, and other approaches to doing grouping. The pro audio industry is a separate industry from the broadcast industry and has been for many years. I actually worked in sound reinforcement in the concert space for a while, and the user requirements and the needs there, or in our audio facilities where we did 64-track mix downs regularly as part of our broadcast facility. It's a different space. It has different user requirements, and those manufacturers have responded to their users and their market. And so there are things to be worked out yet between how Nmos works in an Ember Plus or Dante environment, and many implementations are going with a hybrid environment that ends up with Nmos and Ember Plus or Dante or all of those and some others. And I think what we're seeing is in the areas where the Nmos specifications are stable and have been out there, people can use them, but there's still a lot of work that people are going through, just working through in terms of systemization of all of this. And I really, again, appreciate our BBC colleagues and being willing to talk openly about the systemization issues. And I want to be clear right now, and I think John had said this, that the AMWA has not said we are tackling the control plane and Nmos is the entire control plane and does everything about control. And I said that when I think of control, it's a big topic, and one that no matter who tackles it, we are going to have to do it in bite-sized pieces. And so that's what the AMWA is doing. And in the areas where we have taken bites of the pie here, I think we have delivered, and my hat's off to my colleagues in the Nmos Steering Committee, which is a group that manages the priority and tasking there to get projects out the door. And we'll continue to do that. But, there are parts of this whole puzzle that we're going to have to work through collaboratively in the industry. And we have to recognize also that there are vendors out there who have their own proprietary one-size-fits-all solutions, and those are targeted at particular areas of the market, and that's fine. That's a reality in the market. And there are other systems like Ember Plus, Dante, and others that are fit for purpose in their areas of the market. And overall, we need to work together to figure out where those products interface with Nmos APIs. How can we make those work together in some logical way for the benefit of the industry? So I know I'm speaking for my fellow board members who are here on the call, on the panel, and others that aren't here, to say that, you know, we're dedicated to figuring that out, but we're also dedicated to working on open, interoperable specifications and building on open public standards, and that honestly is our primary focus. We have a few minutes left. I wanted to touch on the tools that might be most useful for standing up Nmos control systems. And Rich, I know you spent an awful lot of time working in this area, and I wanted to give you a little bit of airtime here to talk about the tools that are available that might help people that are trying to work on Nmos and 2110 Nmos systems generally.
So I'll try and be brief. The first thing I would say is there is a whole page dedicated, there's a whole raft of information dedicated to this on the AMWA site, and the key message here is this is all open source software. It's been put into the public domain with all the sources, with all the code, and is completely free. And we actively encourage organizations, vendors to take the code base and to consume it, whether that's in their own product or even for testing purposes. But inside, what we've done is we have basically a complete implementation. So we have a reference Nmos registry, we have a reference Nmos client or controller, we have a reference Nmos node. It doesn't actually move any transport around, but it's virtual, so it does everything it should do from a control perspective. We have a fantastic implementation from Sony and the BBC, where they've built the Nmos testing tool that actually allows organizations, whether that's a vendor or whether that's a customer, to come and test their environments. Brilliant tool. And what we've also done is, because I'm a big believer in simplicity, and a Twitch streamer has got to be able to do all of this, we've also have the concept of Easy Nmos, where we've taken all of those jigsaw pieces, we've containerized them so that they can be consumed on someone's laptop or in the cloud or on a server estate. It doesn't matter, but they're all simple containers that can be spun up with a really simple Docker Compose script. And we call that Easy Nmos because it's simplicity. And then the one final point is, just like Nmos is always going to evolve, the testing is always evolving as well. You know, we're always adding new tests. And I just wanted to call out, you know, there's a piece of work that Rob Porter's currently engaged on, where at the last JTNM event, we tested all of the Nmos clients or controllers manually. Okay, that piece of work was great, but the point is, we don't want to sit there with a tick list and ticking boxes. It just doesn't scale. So Rob is doing a piece of work now within AMWA around automated client testing. And I just wanted to call that out because I see that as a, you know, a big evolution, and automated testing is something that customers can just constantly use going forward. And that's coming down the line as well. So.
Thanks, Rich. I just, to point to those things, I just want to show people on the main AMWA.tv website, there's Nmos at a glance. You go to this box, then you'll find a section down here, how can I use it? And there's pointers to some videos that you and Gareth have done, the Easy Nmos tool. test suites and so on. So people can find those things on this page, as well as quite a bit about other information about Nmos generally. So again, I'll just show you quickly to get to that. Go to amwa.tv and you go to the Nmos at a glance, and you'll get to this page with quite a bit of useful information.